James Davis. This is Elliot Womack, Daniel Carrington, Jesus Valadez, and Joseph Hines. And we're a UT design team working with Zybex Labs. Zybex Labs uses atomically precise manufacturing through the use of a staining telling microscope. Shown here is a control loop diagram for the staining telling microscope. The telling current flows from the sample into the tip. This current is dependent on the distance between the tip and the sample, as well as the bias applied to the tip of the sample. This current then flows through a transimpedance amplifier, which converts it from a current to a voltage. A typical input current would be around 1 nanoamp with an output of around 1 volt, showing a gain of 10 to the 9th. Next, this voltage flows through a processing block. Using signal processing techniques, Zybex Labs is able to create a three-dimensional map of the sample, as well as control the STM tip. In order to manipulate the sample on an atomic level, Zybex Labs applies a stronger current, which is actually able to remove the targeted atom. Through careful placement and removal of these atoms, Zybex Labs is able to achieve atomically precise manufacturing. Potential applications for this include creating a medical device which is capable of rapidly decoding a DNA sequence. This will allow doctors to tailor their medical services to a person's genetics. Zybex would like to pursue those market opportunities, but currently their implementation is a little bit slow. So in order to combat this, they're looking at running multiple tips in parallel, each of them working in order to do this atomically precise manufacturing. Our goal is to reduce the cost of the control loop per STM tip, so as to aid them in their efforts to multiplex these tips. Through meeting with Zybex, we've identified two components, the data acquisition module, or DAC, which costs around $6,000, and the transimpedance amplifier, which costs around $4,000. Daniel and Ellery have been working on the DAC implementation. Their proposed solution uses an ARM DSP on the same board, called a BIGO board, as well as a companion ADC DAC board, which they'll develop themselves. Their solution should cost around $400, and in addition to these cost savings, it will also allow them to do the image processing on board, reducing latency that they currently have when communicating with the computer. Joseph, Jesus, and I have been working on the transimpedance amplifier solution. Our simulations show that we have achieved current circuit operation while also increasing the bandwidth by 8 times what they currently have and reducing the cost to around $400. We hope to have a prototype of this done in the near future in January. We just got our PCB and parts in, so we'll start working on it right away. And the combination of these applications will allow us to reduce the cost of the STM tip per tip, from $10,000 to around $1,000, a reduction of 90%. Through this, we hope to aid Zybex in their goal of effectively multiplexing these STM tips to produce parallel atomically precise manufacturing. Are there any questions? Yeah, I know. I had to rehearse this to get it all in a 3-minute block, but.
Do you have to scan the part like this or the item like this in order to see everything more?
Right, they move it around, and that's what's able to create this map.
Okay. So they do it on a sample basis, or do they try to make a raster scan of it?
I don't actually know how in depth they go. I don't know if anyone else knows here, but.
I think they, via raster scan, they can make images that are really detailed down to the atomic level, so with nanometer resolution. Yeah.
Okay. What is your acceptance test?
We have a prototype, like James said, that is almost complete. We have the parts, the PCB, we're going to build it, and Zybex is actually going to allow us to stick it in the current system, and we're going to see if it works.
Just do a comparison to the old.
Exactly.
Any questions?
So what would we be optimizing? Time and cost?
Right, essentially we want to meet their criteria. If we can give them something else that's even better, then that's excellent, but primarily it's the focus is on cost. So right now our implementation is allowing them to run for the same cost, 10 tips in parallel.
We're also trying to improve the time. Currently they have a DAC solution that goes through USB, which has terrible latency, and it takes them up to 5 minutes to get an image. With this solution, with the ARM processor on the DSP, it should be able to get it in under a minute.
The main constraint for our project is that we want our components to be a drop-in replacement to work with every other component in their system. That's so compatibility.
The cost is based on what quantity?
This is just for like an individual, like one transimpedance amplifier and one DSP solution. And again, there's a significant price tag for the transimpedance amplifier because ordering a PCB is really expensive just for one, especially when you factor in the shipping cost, which is what this price estimate uses. So it would, if they ordered a lot of them, it would significantly reduce the cost of the transimpedance amplifier.
You're developing your own transportation?
Yes, we've designed, simulated, laid out, and we actually just got the PCB. We have it over at our poster, so they can come by and see us.
You haven't turned it on yet?
No, we haven't actually soldered the components to it. We just got it yesterday afternoon, so not quite that quick.
Okay. 5 minutes. Let's thank our speaker.